Hi students, today I want to discuss about interhalogen compounds. Okay, here interhalogen compounds. Interhalogen compounds means in between halogens. Here, if interhalogen compounds are taken, X means considered as a halogen, and the other one is also X dash, it is also a halogen. And this timing, these interhalogen compounds are mainly four types of halogens are there. Interhalogen compounds. First one is XX dash type, and second one is X3 dash type, and the third one is X dash 5 type, and the fourth one is XX7 dash type. Okay, so here, what is X here? It is generally a big size halogen. Big size halogen. And what is X dash? A small sized halogen. Small size halogen is considered as X dash, or this is called as less electronegative. Less electronegative halogen, and this is called as more electronegative halogen. So generally the central atom, it is X is a central atom. Generally central atom is a bigger halogen atom or less electronegative halogen atom. And X dash, here X dash means it is a smaller sized halogen atom or more electronegative halogen atom. And here in these interhalogen compounds, generally why big sized halogen and small sized halogen is taken means a big sized halogen always can accommodate more number of small sized atoms around it. So big sized halogen atom can form X dash type up to 7 also. Means for example IF7 is taken, we can't get for chlorine ClF7 because chlorine is small sized atom, it cannot accommodate 7 fluorine atoms around it, so this becomes unstable. Whereas iodine is a bigger sized atom, it can accommodate 7 fluorine atoms around it, so IF7 is possible. Okay, so always if a polyhalogen interhalogen compound is forming, the big sized atom is forming a more number of a big sized halogen atom can accommodate more number of small sized or more electronegative halogen. So XX7 or XX5 is mainly formed by the large sized iodine bromine type, not by the chlorine. Okay, that is interhalogen compounds. Mainly we have four types of interhalogen compounds. And how we can prepare these interhalogen compounds? The preparation methods when we are taking direct method, it is used here. The direct method is used for the preparation of interhalogen compounds. In this, what is the direct method means? Suppose Cl2 is reacting with F2 at 437 Kelvin temperature. In equal volumes we are taking this. Equal volumes of Cl2 and F2 are used. When Cl2 and F2 are used in equal volumes, then it is forming ClF, chlorine monofluoride. And similarly, if Cl2 and F2 is taken, but F2 is taken in excess, fluorine is taken in excess, and here we are using 573 Kelvin temperature, then we will get ClF3. 2ClF3 is formed. This is a chlorine monofluoride, chlorine trifluoride preparation method. The next one, bromine, Br2 reacts with F2 in equal volumes. In equal volumes to form 2BrF. And similarly, Br2 reacts with 5F2 in excess. Fluorine now taken as excess, then we are getting 2BrF5, bromine pentafluoride. And iodine reacts with chlorine in equal amounts. Here, in this reaction, this is diluted, the solution is diluted with nitrogen or with water. Please remember, solution is diluted with nitrogen or with water to get that BRF. And I2 plus Cl2 in equal volumes. When reacting, it forms 2ICl, and same I2 reacts with Cl2 to form ICl3 when we are taking chlorine as excess. So these are direct preparation method of interhalogen compounds. Okay. The next properties of interhalogen compounds. In this first point is, all the interhalogen compounds are covalent molecules. Very, very important. They are covalent molecules because they have less electronegativity difference, so they are covalent in nature. And second point, very important, they are diamagnetic. So they are diamagnetic. They are not paramagnetic, they are diamagnetic. Third point, they are mainly present in the solid or in the liquid form at 298 Kelvin. At 298 Kelvin means it is room temperature. And there is one exception, except CLF, which is present in gaseous state. And next point, IF is the very unstable interhalogen compound. And next, ICl3 easily undergoes to dimerization to form I2Cl6 times. The iodine trichloride undergoes to dimerization easily to form I2Cl6 times. Okay, this is main properties. And next and important point is reactivity. Here, reactivity of interhalogen compounds. When we are comparing the reactivity, fluorine is the highly reactive molecule, and the next one is interhalogen compounds. The most reactive is fluorine, next one is interhalogen compounds, and the next one is halogens. Okay, so this is the reactivity order. So which is most reactive one means fluorine, because the fluorine is small in size and more interelectronic repulsions are present. So fluorine is highly reactive. And what is the next one means interhalogen compounds. Generally they may give like which is more reactive, halogens and interhalogen compounds. When you give commonly, interhalogen compounds are always more reactive than halogens, but particularly or specifically if they mention about fluorine and interhalogen compounds, always please remember fluorine is more reactive than interhalogen compounds because of small size and because of more interelectronic repulsion. Due to the small and interelectronic repulsion, this is having more reactivity than interhalogen compounds. After interhalogen compounds, halogens are more reactive. That is the reactivity order. And suppose if you are taking the reactivity of different halogen, ClFn is more reactive than BrFn. It is more reactive than IFN. Okay, ClFn is more reactive than BrFn and IFN. Here this order is followed if n is same. N is same. Here means suppose ClF3 we have and BrF3 we have and IF3 we have. Then in these three compounds if you are taking, which is more reactive means trifluoride, chlorine trifluoride, next is bromine trifluoride and next is iodine trifluoride. So the reactivity order when n value is same, we have this type of order. Okay, when n value increase, what happens? The more chlorine atom, n value higher n value is having more reactivity. For example, I will give. For example, if you have ClF3 and if you have ClF, which is more reactive means ClF3 is more reactive. Similarly, BrF5, BrF3 and BrF. Similarly, IF7, IF5, IF3 and IF is present. Then this is the reactivity order. Okay, trifluoride is more reactive than monofluoride. Suppose if these three are present, how? Next, ClF3 is more reactive than BrF5, more reactive than IF7. Next, what is present? ClF is more reactive than BrF3, more reactive than IF5. Next, BrF is more reactive than IF3, is more reactive than IF. So this is the reactivity order of different interhalogen compounds. So when n value is same, chlorine halides are more reactive than bromine, bromine halides are more reactive than iodine. But if n value is different, then this is the order. More is the n value, more is the reactivity. Okay. Next, all these interhalogens undergoes to hydrolysis reaction. Please remember, this is also important one. Hydrolysis reaction of interhalogen compound. And in this hydrolysis reaction, suppose if a monohalide is taken, this is called as interhalogen compound and monohalide, chlorine monofluoride. If this is undergoing to hydrolysis, what is the product means? HF and HOCl is formed or HClO is formed. Next, this is monofluoride. And next, ClF3 is taken, chlorine trifluoride or any trifluoride. It is undergoing to hydrolysis and this is forming again HF plus HClO2. And next, suppose BrF5, we are taking BrF5, then it reacts with water or undergo hydrolysis, again it is forming HF plus HBrO3. And next, IF7 is taken, then here H2O, it is forming HF again plus HiO4 is formed. HiO4 is formed. Here, what is the similarity or how we can remember easily means, please see, monofluorides gives hypohalous acid. It is forming hypohalous acid. And trifluorides are forming, this is called as halous acid. It is known as halous acid or it is called as halides. Salts of halides are formed. Pentafluorides are giving halic acid. This is called as halic acid. HBrO3 means that is a bromic acid. IF7 heptafluoride gives perhalic acid. This is called as simply periodic acid. So please remember, when we are taking the monofluorides, we will get hypohalous. When we are taking trifluorides, we are getting halous acids. When we are taking pentafluorides, we will get halic acids. When we are taking heptafluorides, we will get perhalic acids. And in this balancing, see how we can balance easily means, first of all, how many fluorines in the reactant? 1. So I am writing 1 HF only. Next, here 3 fluorine atoms. So I am writing 3 HF. 5 fluorine atoms. So it is 5 HF. 7 fluorine atom. So it is 7 HF. So this 1, 3, 5, 7 we are writing as 1, 3, 5, 7. And next, how many hydrogens we need? See here, 1 plus 1, 2. So here H2 is present. So 1 molecule of water is enough. Here 3 hydrogens plus 1 hydrogen, 4 hydrogen. So here what we need? 2 H2. And here 5 plus 1, 6 hydrogen. So it is 3 H2. 7 plus 1, 8 hydrogen. So it is 4 H2. So 1, 2, 3, 4. Here 1, 3, 5, 7. So this is balancing of this reaction. And so here generally remember, any halide, interhalogen compound reacts with water and gives hydrolysis process. In this hydrolysis process, if monohalides undergoes to hydrolysis, hypohalous acid, trihalides halous, pentahalides gives halic, heptahalides gives perhalic. And one more important thing, why can't we get HCl and why can't we get HYF? So you may have a doubt, or I am asking this. HF is only formed in always, and other compounds are formed here. Here HCl and HYF, why can't we get? C and F is there, H and Cl combine to give HCl also. No? Why we are not getting this? This is not getting and this is not getting. Why we are getting only HF and HOCl, HClO2, HBrO3, HiO4 only? Always remember, whenever the halogen having higher electronegativity, that will be converted into a halide ion only. Even if it is, suppose we are taking BrCl, for example, BrCl we have. BrCl plus H2O. What is the product? Can you guess? Which is more electronegative in these two? Yes, chlorine is more electronegative. This is more electronegative. So more electronegative atom plus hydrogen is released as HCl plus the remaining compound. It is forming HOBr. So always remember, the more electronegative atom of the interhalogen compound with hydrogen forms a hydrogen halide. So here always we are having fluorine, so we are getting hydrogen fluoride only. If chlorine and bromine is present, Cl is more electronegative. So we are getting HCl, hydrogen chloride, and HOBr, hydrobromous acid. Hypobromous acid is formed. Okay, this is the hydrolysis reaction. Important thing, basing on the given interhalogen compound, write the halide and halous or halic or perhalic or hypohalous acid. Okay. The next another point, important point. Please remember, in the halogen chapter only we study about this, that is pseudohalogen, and sometimes they are asking about pseudohalide ion, or pseudohalogen. What is a pseudohalogen or a pseudohalide ion? Here pseudohalogen or pseudohalide ion means what? The ion or the species, mainly pseudohalogen, how we can define means the ion or the species which has similarities in their properties with the halogens. Similarities in their properties with chlorine or with bromine or with iodine mainly, not with fluorine. So any species, an ion or a molecule, any species which has a similarity with chlorine, bromine, iodine properties is called as pseudohalogen or pseudohalide ion. The best pseudo halide ion is Cn minus. In the examination previously they asked this question, which of the following is a pseudo halide ion? That is Cn minus. Okay, and if it is dimerizes, then it gives a molecule Cn taken twice. This is called as a pseudo halogen. This is called as cyanogen, commonly called as cyanogen, and this is called as a cyanide ion. This cyanide ion. And another important pseudo halogen, this is the best and important one, and another one Cn minus. This is called as thiocyanate. Thiocyanate. And OCN minus and N3 minus, SeCN minus, cyanate ion and azide ion and selenocyanogen, cyanide ion. And similarly, SCN taken twice, this is called as thiocyanogen, and SeCN taken twice, this is called as a selenocyanogen. So these are pseudo halogen molecules and pseudo halide ions. So whatever it may be, pseudo halide or pseudo halogen means you always remember that is having similarities in their properties with chlorine, bromine or iodine type halogens. Suppose Cn is taken. What is the similarities with Cl minus or Br minus or I minus? We will give one example. AgCN if you are taking and AgCl if you are taking, both doesn't dissolve in water. They doesn't dissolve in water, but they dissolve in ammonia. Here they doesn't dissolve in water, but they dissolve in ammonia. Similarly, CuCN taken 4 times minus 2 we have. Same as CuCl 4 times minus 2 complex. Okay. Similarly, COCN 6 times minus 3 complex we have. Similarly, COCl 6 times minus 3 complex also we have. Means as like chloride, it is cyanide is also forming a same type of complexes. So that is the similarities just observed for the pseudo halogens with the halogens. Okay, this is important point.